column proofs.
Guys, today's gonna be a fun one, okay? Similarity proofs. How can you organize the deductive reasoning of a geometric proof? Write a two-column proof. Prove geometric theorems by using deductive reasoning. Let's just let you know. This one is different. It's a different lesson. It's a tough lesson. Okay?
We got to do.
Yes. You have to know what we're talking about when we talk about proofs. Lucky for you guys, the board's messed up.
Let's go.
Yes. You don't have to write this down. Just visualize what's going to happen here. When we're writing a proof, it's important that we justify each logical step with a reason. That's why I've been such a pain in the rear about our definitions. Right? It's important to know the difference between complementary and supplementary, congruent and similar. You can use symbols and abbreviations, however, they must be clear enough so that anyone who reads your proof will understand them. So, what are we talking about when we talk about a proof? Proving a point. It's like what we did for the warm-up, right? Okay? Somewhat like we did for the warm-up, okay? We'll start with a hypothesis of some description. We're going to use a definition, a postulate, a property, or a theorem that will reach a conclusion. Let's do this. I've never done this. Maybe you guys probably aren't on this level yet. In history, we do the same thing. Okay? When you write history, I know right now for you guys, history is just a bunch of facts. Okay? Probably still. I don't know how they teach history here. Most high school level secondary education, most secondary education history classes are just this date did this, and 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 this person did this, and this person died, and these people got together, and these people did this, and for about, 4 months, you'll just hear that, and it's like, okay, we started in 1492, and now we're here, okay? Well, check it out. You'll get to a higher level of history. Your desk's outside. If you don't mind grabbing it and bringing that. Okay? You'll get to a higher level of history where you actually don't do that. Actually, what you do is you make a hypothesis about something and you piece together your hypothesis to determine if it's true or not. Okay? And it happens on all sorts of levels. What was the cause of the Civil War? What were the effects of World War II? How was the Cold War productive versus inefficient for American society? So on and so forth, okay? But like I said, you'll get to that at a different level. Okay? Today, we need to write down a couple different theorems. Right? You need to write down the definition of a theorem, for sure. Theorem is any statement that you can prove. Very simple definition. Any statement that you can prove. Okay? Once we've proven a theorem, we're going to be able to use it as a reason in later proofs. Write down for me what's called the linear pair theorem. Linear pair theorem says if two angles form a linear pair, then they are supplementary. Okay? If two angles form a linear pair, then they are supplementary. For those of you in the back that can't see it, let me help you out. Okay. Also, right now, what we call the congruent supplements theorem. According to that theorem, if two angles are supplementary to the same angle, or to two congruent angles, then the two angles are congruent. So make sure, based on this slide, you've got your definition of theorem, your definition of linear pair theorem, and there we go. Just kidding. Your definition of congruent supplements.
What's a linear pair?
Linear pair. What word is embedded in linear pair? Way more money. I have to do more too, so that's okay. All right, a geometric proof. Actually, I worked more in college football. I worked more, got paid less. All right, we'll get back to it. Yo, Joe Beth, what's up?
I don't understand the congruent supplement theory.
Okay, we'll talk about it later. A geometric proof begins with given and proof statements which restate the hypothesis and conclusion of the conjecture. Here's what you need to make sure you write down. We call a two-column proof. A list of the steps of the proof in the left column. You write the matching reason for each step in the right column. Okay? Statements on the left, reasons on the right, or justifications on the right. Statements on the left, reasons on the right. Okay? So, we'll see these today. And I would be too, because this is what it might look like. Alright? Fill in the blanks to complete. Here's what a two-column proof looks like. Given, I don't even know what this means. Given that we have line segment XY, I'm trying to prove that line segment XY is congruent to itself. This is possibly the worst example of a two-column proof that we could ever give, but we did it anyway, okay?
Wow.
I have XY, I have line segment XY, correct? Is line segment XY equal to itself?
Yes.
Yes. What makes that true?
The reflexive.
The reflexive property, right? We wrote that down last week,
Yep.
correct?
Don't.
I wrote an example and I said, was AD congruent to itself in the two triangles? And all of you went like this. And some of you weren't sure why you were going like this, but all of you went like this, okay? Yes, it's congruent to itself, okay? Well, that means that if the particular, if the reflexive property is true, that means that these segments making up those side links are congruent to each other. That's what the definition of congruency means. If they're equal to each other, they're congruent to each other. Okay? Horrible example, so let me move on. But it was a short one. Okay? Here is a more appropriate example of what you'll see. Fill in the blanks to complete a two-column proof of one case of the congruent supplements theorem. 1 and 2 are supplementary, and 2 and 3 are supplementary. Oh, look at that. Okay? 1 is congruent to 3. Okay? We start off. Every single proof will start off like this. It'll have a statement, and it'll have, you see what this word says? Given. And do you know where you look to find your given information? Right here, where it says given. Okay? So given says 1 and 2 are supplementary, and 2 and 3 are supplementary. So which one of these is going to go in A? Which one would I put right there?
Are the A?
Yeah, A. Okay? Who is unsure why I'm putting A there? Please be honest.
No.
Not a problem. It says given right here.
1 and 2 or something.
Right? It says given right here. It says given right there. So whatever follows that,
You put in there.
that's going to have to go right here in the statement. Okay? You see how it switches sides?
So
Right?
2 should be B and 3 should be C.
Well, let's just do it like this. We know that A is going to be right here. Okay? Once I've used it, it's gone. I don't have to worry about it. That's the beauty of the fill in the blanks. Okay? Number 2.
Wouldn't that be C?
Okay? Hold on. Wait. Number 2 says the measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 2 plus the measure of angle 3 equals 180. How do I know these things? I took my definition of supplementary and applied it, right? Got me? Supplementary means they have a sum of 180. Okay. First step, 1 and 2 are supplementary, 2 and 3 are supplementary. Okay, that's great. Second step, the fact that they're supplementary, what does that mean? It means that 1 plus 2 is 180, 2 plus 3 is 180. How do you know?
So would that be 1 and 3?
The definition of supplementary angles is how I know that's what is true, okay? All right, do you just see a blank here?
No.
No, okay, good. All right, B, fill in the blank B. Yo, what's your question?
Is there an easy way to do this?
This is the easiest way, okay? All right, B, if, let me see here. Substitution property. What are we getting at here? Oh, I'm sorry. 1 plus 2 equals 2 plus 3. Oh, okay, I got it now. All right, so if this is true, it means that this has to be true, right? If, yeah, it says it, right? If they are both supplementary, that means that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Okay? If they are both supplementary to the same angle, what's the connecting angle here? Angle 2, right? It's involved in both of these steps. Got me? Okay? That means that they're equal to each other. This would be B. Is it a coincidence? Yeah, pretty much. Okay? What's going to happen now is this. Okay? Through the reflexive property, you can just follow this proof along. Through the reflexive property, angle 2 is equal to itself. What would make angle 1 equal to angle 3? That would be what we call the subtraction property. Okay? How'd you get there, Mr. Hobbs?
Subtracted.
I subtracted the measure of angle 2 from both sides of this equation. Okay? Got me? I subtracted the measure of angle 2 from both sides of this equation. So this was C. Okay? What does that leave me with? That leaves me with the following. Angle 1 is equal to angle 3, which means that they have to be what? Congruent. Okay? Congruent. Now, let me do this.
Wait.
Oh no, we got the next one. I
Still didn't answer my question.
then
Like,
we're
what's
gonna
that
get,
thing
I didn't hear your
like?
question.
So why do we have to do just why do we have to answer it with so many?
Because you have to, it's a logical reasoning. Okay? Logical reasoning. The logical reasoning says, I can't just say 1 and 2 are supplementary and 2 and 3 are supplementary, and by itself I know 1 and 3 are congruent to each other. Okay? It wants you to take, I did this with Joe Beth, right? It wants you to take each particular fact, each bit of information that you're given, and use it to get to the next step, to the next step, to the next step, to the next step, to finally prove your point. How do you know if you skipped a step? You will, and I'll tell you when you do, because I promise you will. Yes, ma'am.
What's the symbol after 2 and 6?
2 and 6.
So,
Cut me out.
What's the little symbol at the end?
Here, congruent angles.
So is there always supposed to be 6, right?
Nope. Sometimes there's 15, sometimes there's 3, right? Remember how I gave you this example? Look, there's a 3 one. This one's easy. Oh, sometimes there's 6. Sometimes there's more. Watch this one, okay? Given that 1 and 2 are supplementary and 1 is congruent to 3, prove that 3 and 2 are supplementary. Do you notice what I did here? Eh? Eh? Heh. Okay? Yeah, sometimes they don't give you the columns. Alright? Yeah, we have what's called a paragraph proof, where they literally want you to write out everything, word for word, and it is stricter. Alright?
So often you do that about a cash register. You make it like-
Yeah.
like that's the reason.
Remember Tom Brady, right? Okay? I told you it was gonna be, you gotta justify your steps. Alright, check it out. What would this answer look like? Something like this? Let's go over it. Hey, if nothing else, by the end of the week, you better get this.
so this test that we take.
What do I start with? Given. Y'all hear me? I'm telling you right now, I will give you credit, and I mean it. I will give you credit if you start every proof with given. Okay?
How much credit?
You'll get credit. I didn't say you'd get it completely right, but I will give you credit. I will not count off if you get that part.
You'll at least get
Okay? You'll at least get 1 point.
So we.
1 and 2 are supplementary. What does supplementary mean?
45 and 45.
Wrong. What does supplementary mean?
90 and 90.
Well,
Well,
something
that you add together to get 180. Two sums that equal 180.
Two angles that have a sum of 180.
That have a sum.
So all I do is I take this particular piece of information and I put it into, think about it, I'm just taking the definition of supplementary angles right? Just taking that definition and putting it on paper. What does it mean when they're supplementary? It means that the measure of angle 1 plus the measure of angle 2 equals 180. That's all that means. I stop. I go to the next one. It says 1 is congruent to 3. If 1 is congruent to 3, what does that mean about their measurements? They are congruent, or starts with an E. Equal, right? All it means when we say congruency, when we say they're congruent, you got to be able to make this transfer. Congruent means equal, the exact same, identical, right? So if I told you, hey, I'm looking for an angle out there that's congruent to 45, what would you say? 45. 45 equals 45, right? That's the definition of congruency, okay? All right, this is where, in this particular proof, this is where it gets real, yo, okay? It says the measure of angle 3 plus the measure of angle 2 equals 180. How do I get that step, Mr. Hobbs? I'll get this question more than anything else, okay? Here's how. 1 plus 2 is 180. 1 equals 3. So what can I do with 3? It just gets to, yeah, I put it where 1 was. I substituted in. See, now I told you, you get it. Eventually, right?
But without knowing what 3 and 2 are, how do you know it's not switched around on the bottom one? Like, how do you know that they're not? This would be so much easier if we knew what the angles were first.
It would be so much easier.
Is it going to be on the test?
But it's not. It's never that way. Because they're not, hey, because they're not problems. They're theoretical problems. That's why we have proofs.
Well, I'm theoretically.
It's here to ruin your life. Guys, it's here to ruin your life. I'll just let you know. Okay? Finally, oh yeah, just wait till your grades get back. Right? 1 plus 2 is 180. 3 plus 2 is 180. What does that mean about 3 and 2? They are.
Supplementary.
Yay! You're already getting it. All right. All right. We got one more. Actually, we're not even going to do this one. Write a justification for each step. Given that the measure of ABC is 90, the measure of angle 1 is 4 times the measure of angle 2. That doesn't really help me out. Okay? Nope. But you wanted numbers, so that'll help out. Okay? First off, how do I know that ABC is 90 and measure of angle 1 is given? Thank the Lord. You get credit, all right?
Let's go.
First step is given. All right? You got me? You got. And why do we do that? Because you have to start somewhere,
See, I'm
right?
going to do the first
You have to start somewhere. You got me? Y'all ever seen the, what is that? What's that show? Coach Murphy loves this show. Naked and Afraid.
Yeah.
Okay? Right?
Supplementary.
Naked and Afraid. What's the object? What's the object of Naked and Afraid?
Get naked.
No, not to be naked. To do what? It's to survive, right? And what do? They get naked, but they what? They drop you off somewhere, correct? You don't know where you're getting dropped off, right? You get a bag of supplies and they say you've got so many days to get to such and such a place, right? But think about it. They have to drop you off somewhere, correct? These problems are the same way. You have to start somewhere. You have to start with something.
And then just
Okay?
show up and we're 180.
That's the good part, is that you get a starting point, and you get a starting point, and you're gonna get a finish. They're gonna tell you what to prove.
Where you
It's all the in between. I'll show you how they got 18. First off,
Oh,
check it out. Angle 1 plus angle 2. Angle 1 plus angle 2 equals the measure of angle ABC, correct? Okay? Yeah. What did we call that? Nope.
Oh, I get it now.
What did we call that? It was about, I don't know, 6 weeks ago, 5 weeks ago. Hey. The angle addition postulate. The angle addition postulate tells me if I've got a bigger angle, correct, like ABC, I can take the measures of the angles inside of that big angle, add them together, and I will get the measure of the big angle. right? We did problems like this. You wanted numbers involved, right? We're about to get there, okay? What does this mean? Well, then I take my information about angle 1. What do I know about angle 1? I know that
It's worth one.
it's, nope,
4 meters.
Oh, that's it.
no. 4 times the measure of angle 2. Angle 1 is 4 times the measure of angle 2. If angle 1 plus angle 2 equals angle ABC, that means that 4 times the measure of angle 2, right? 4 times the measure of angle 2 plus the measure of angle 2 equals 90. Mr. Hobbs, how are you getting all of that? I'll tell you how, okay? I was given this information and I substituted it right here. I was given this information and I substituted it right there. See, right? It'll click a little at a time, okay? When I add 4 times the measure of angle 2 plus 1 times the measure of angle 2, how many measures of angle 2 do I have? I got 5, right? This is back to algebra. I got 5 times the measure of angle 2. Y'all know what to do here. I'm trying to find the measure of angle 2, divide both sides by 5. The measure of angle 2 would be 18. What would be the measure of angle 1?
72.
How?
Because you just subtract 18, or subtract, 18 from 90.
Okay, and to make sure it's airtight, right? What else do I know about angle 1? It needs to be how much?
4 times.
It's 4 times, so you, or you multiply 18 times 4.
So it's like a math debate.
2, 3, 72. Then you add 18.
This is a
Okay.
math debate with yourself.
If you want to see how those would work, that's how it would work. Okay? Start with your given. Angle addition postulate. Substitution. They call this simplify. Okay? I'll be honest. Once you get down here, all right, once you get past here, you say simplify. You can say add the numbers, whatever it was. For right now, you're okay. Okay? How do we go from 5 times the measure of angle 2 to the measure of angle 2? We divided both sides by 5, right? Okay? Now,